Yeah, I'm Tyler. Um, I've been at Elastic now for nearly 2 years, and I have the interesting role in an open source company of looking after really two things: product marketing and technical marketing, and then developer relations and evangelism. So basically, my job is to have a team of folk that talks about the really cool things that other people build, which is really actually kind of an enviable job to have, and you should all do it. It's fun. My background is actually in the database space, in everything from sort of early big data, which was like sensor imagery, hyperspectral analysis stuff. I started my first consulting company when I was 17 in the database space as well. Spent time in payments, spent some time in the government sector, and then made the jump to open source distributed systems and fell in love with it and have been there ever since, with this weird little brief foray into storage, which that was a bad idea. Don't do storage. Nicholas asked if we could talk about, all flash storage is really cool, but also after, an extraordinarily long amount of time talking about your marketing message and you're like, enterprise risk reduction. Yeah, it's a bit of brain damage. So Nicholas asked if we could talk a bit about machine learning. And this is the newest thing in the Elastic Stack. So I'm going to preface some of what I'm saying with, once I dive into the live demo, it's beta code. Like, it's not even a build candidate. So you're going to see some things that may be a little bit funky, but bear with me. And then I'll point out some other fun stuff in Kibana too that I just noticed from the earlier presentation that we've made some little tweaks on that I think are actually kind of really cool and useful. But I wanted to start by talking about what machine learning is. And the reality is, as we just heard, right, much of what Elastic is about as a company is allowing you to extract valuable and useful information out of a big corpus of data, right? I had some really interesting conversations this morning about library style data, or conversations this afternoon about logging data. And I was in Germany earlier talking with a completely different retailer about their point of sale data. And really the reality is there's a bunch of data and you want to extract value from it. And Elasticsearch, sort of as history for those of you who don't know us, began as an open source project, and it was sort of dreamed up by our almost now CEO, Shai Bannon, who was building a recipe search tool for his wife as she was going to culinary school, because storing recipes was like a pain in the neck. And so we've always had this core foundation of search. Like, that's where it all began for us. And search is still one of our biggest use cases. People like, eBay marked plots, right? Or Wikimedia Foundation. Like, you go to Wikipedia and you type something in, right? That's Elasticsearch, right? Those are easy things to reason about. But what we discovered is that logging is really a search problem. I have a lot of data. I want to get some insight out of that data, and I want to find something quick and find relevant information around it quickly. So that's kind of a search problem as well. And so extracting this information starts with search. And then we added this capability called aggregations, which I won't dive into in great detail, but ags are super important because I'm able to do calculations on the data that I have persisted. And then if I have these cool searches and I have great aggregations, then I probably want visualizations on top of that. And then about 6 months ago, we joined forces with a company that was called Prelert. And we added machine learning to the Elastic Stack. So we've been working for the last 6 months on integrating it tightly, actually as a node type. So like you saw before that nodes have attributes, like there's master nodes and there's data nodes. And in 5.x and above, there's also ingest nodes, which is how some of the cool Beats capabilities work. And then machine learning will be a new node attribute. The problem with machine learning is that it's this really, really broad umbrella term that applies to a whole bunch of different use cases, and it's super popular. So it's wildly often misused and overused. And we had a lot of back and forth on do we even want to use the term? Because so many people use it in so many terrible ways. And it applies to a wide range of things. Like, am I doing image recognition? That's machine learning. Am I doing language translation? Well, that's machine learning. Recommendations, like I log into Netflix and Netflix is like, hey, here are things that you may like. That's based on machine learning. Or anomaly detection. There's a whole wide range of things that this umbrella term applies to. But what we're going to talk about is training a model. And so, yeah, hey, little bouncy guy. That's from the keynote that we did at Elasticon. And I just liked that our designers made a robot that bounces. So I stole him and put him in a deck, which makes this deck something like 30 meg, even though there's 8 slides, because this is like the highest resolution image ever. Because it was designed to be projected on like a 40-foot wide screen rather than at 1024 by 768. Tommy, whose name I can't pronounce his last name, from MIT CSAIL, is a professor. He studied in Helsinki, Finland. He's written a number of extraordinarily detailed papers with things like multivariate analysis and neural networks, and like he focuses on this notion that machines can learn things and can do things that we as humans can't. And so he began to categorize the machine learning space into discrete sort of buckets of things. And that's supervised learning and semi-supervised and active learning and reinforcement learning and transfer learning. But what we've focused on sort of through our participation with the Prelert crew and others is really a subset of unsupervised machine learning, which is anomaly detection in time series data. And we'll talk in a minute about like what periodicity means and why time series matters, but this is what we're focused on, is identifying something interesting in data that has some measure of regularity to it over time. So an example of that, and sort of probably the most common example you think of, is the question like, I have average orders per minute over some period of time. Has my order rate dropped? And visually, you can look at this and be like, yeah, there's obviously an anomaly, and it shows up right there. But the question is that an anomaly? Or is this bottom piece of the curve that if this was slightly higher resolution, you would see is different, an anomaly? Or is this here an anomaly? Or is that expected? So there's some anomalies that are obvious, right? And we talked a little bit about this notion of alerting, right? Be it a last alert or alerting in XPack, powered by the Watcher API, but calling things by things that don't really say what they are is sometimes hard. Also, never name something Marvel because Disney owns the copyright. Turns out. Yeah, I was always like, it'll be a problem if that, it'll be a great problem to have if that ever happens, but great problems to have are still problems. So in alerting, right, alerting is based on this notion of a threshold. So if I'm looking at order rate falling significantly, and I define a threshold that in this case is somewhere between 0 and 100, and I say, if it goes below, like, let's just pretend that's 20. If it goes below 20, send me an alert, because there's a threshold that it has passed. Would that have triggered? Yeah, maybe, maybe not. I could say if it goes below 20 and it's, not between the hours of noon or whatever time this would be, like 9 p.m. and 5 a.m. or whatever, right? Then send me an alert. Would it have triggered then? Again, probably not, right? So alerting is great when you have an obvious threshold, and there's some really cool things that alerting can do, like, hey, by the way, your server's out of disk space. I actually got on a WebEx this afternoon, and it was with a big company who remain nameless, who was having an internal Elasticsearch meetup and asked us to join them. And it was awesome. Like, it's really cool for me to hear what people are doing with the Elastic Stack. And they were like, hey, Tyler's with us. Does anyone have any questions? And the guy was like, yeah, my cluster's red. I was like, oh no, that's like not the first question you want to get when you're on a WebEx with like very large organization. And I was like, cool, let's look at the cluster health endpoints. Let's look at the allocate endpoint. Okay, you have 205 unassigned shards. Yay, you're using 5.2 or above. Let's look at the allocation explain API. And it turns out that he was using 97 out of 100 gig that was available on that node. And I was like, yeah, well, that's why. And he's like, oh, okay, great, right? So yeah, like disk space matters. Monitor your disk space. But you can say, when I'm above 85% of total capacity, send me an alert. That's a great alerting condition. What you can't say is, if this is outside of a normal behavior, let me know. And that's what machine learning is designed for. And so there is actually a configurable threshold in Elasticsearch. The default is 85% of disk utilization before it stops assigning shards, because of that exact thing. How he got to 97 of 100 gig, I have no clue, like physically how that was achieved, but fortunately it was a test environment. So the idea with machine learning is to use models to predict future behavior. So how does past behavior influence the current time and be predictive for this data set that I'm looking at, and then using those predictions to make decisions, right? I'm going to send an alert. I'm going to warn you about something. I'm not going to belabor that. The other way of looking at it is this notion of entity profiling. You can't see this because it's too small. So my apologies. When we put it online, you can see it then. But these are actually user agent strings, right? And they're like, hey, this is a get, and this is a get, and this is another get. And so this is someone interacting with a website because it happens to be like, openmin.js and CSS themes, right? So this is someone interacting with a website. This was actually from the Prelert website. And the notion of doing entity profiling is saying, at 10 a.m. on a Tuesday, someone who comes to my website usually clicks on 4 or 5 things, or 10 things, or 20 things, or whatever's appropriate for your website, or your corpus of data, and then they go away. If someone comes and they click on 4,000 things in like a minute and a half time span, something anomalous is occurring. And so if I profile what a normal entity looks like, then I'm able to actually define the anomaly of an atypical client. Somehow I got 2 extra slides in there. So then I'm able to display the anomaly of an atypical client. Now, there's a whole lot of like super scary math that goes into this. And I say super scary math, and I was a theoretical mathematics and philosophy major, which is 2 like completely useless fields of study if you ever want to work with computers. Practical maths are where to go, right? But yeah, I thought theory and topology was important. There's a talk from Elasticon. So Elasticon 17 just happened recently in San Francisco in March, right? Was it March, Nicholas? Yeah, happened in March in San Francisco. All the videos are on our website. Unfortunately, like you have to put in an email address. Sorry. Doesn't necessarily have to be your email address, although our marketing team would love it if it was, and our demand gen team would be really mad if they heard me say it. Put in your email address, please. And there's a talk not only about machine learning, where the CTO from that company, who's now sort of the tech lead for the project now, talks through it in great detail, but there's actually a maths deep dive where the guy who has spent his time writing the algorithm talks through how it works. It's the sort of deck where like there's 5 or 7 slides in a row that are just equations, right? It's the great kind of terrifying. There's also a paper about it as well. And as we release this in beta, the paper will be available if you want to dive into the algorithm itself. So yeah, that's enough of me talking at you. Let's poke at it a little bit. So I am connected to someone's hotspot, and from that hotspot to an Elastic Cloud cluster that's being used by other people. So bear with me at the bits where it's slow. This is Kibana. This is Kibana 5, so you can see that it looks a little bit different than Kibana 4 did. A couple of things that I just want to sort of poke at real quick. Discover view is actually where most people start in Kibana, right? I've got a bunch of data. I want to kind of look and see what shape that data is taking, what information is in there. In this case, we're going to look at the IT ops metrics. Well, let's look at the last 5 years worth of IT ops data that's in here. Here's what an entire piece of data looks like. Cool, so I've got, 500, 600, some odd thousand records in there. Let's add host name as a field, because host names are interesting. And let's add maybe the physical host and the type. All right, so let's look. Yeah, sure. If I could find the plus on your keyboard. There it is. Yeah, that's a little bit better. So something to start with. Let's start by just typing in EXS and splat. All of the keys are in different places. You're going to have to bear with me as I type, too. Right top?
On the right top, there's a Swiss German sign. No, on the screen on the right top.
I was there. This one here? Yeah. Ha. Let's see. Now I know. Now I won't know where things are. So we'll see how this goes. Cool. So let's go back. Let's go back to this. So I'm going to actually filter for this physical host. You saw when we came from the filter view in Kibana 4 into the filter view, the visualize view into the discover view, which is really just applying a filter, right? I've done the exact same thing here. I just don't have any dashboards built or visualization. So I'm doing it in Kibana. You can see that in this case, I have this highlighting that only occurs on EXS server -acme 1. Before, like if you were in a user agent string, and I don't happen to have a good one to show you, it would have highlighted the entire string rather than just highlighting the segment of data that you're trying to look for. It happens to be a very small thing that's coming out in the newest release of Kibana, but it's one that's like super valuable if you're actually trying to search through a bunch of data. There's also this, which I super love, which is view surrounding documents. So that was a document that I was looking at. This is like, let's say this is a log line. I want to, hey, there's an error in that log line. I want to see what happened before or after it. This notion of, let's call it event context, I think is one that's super compelling, particularly if you're pulling in data from a bunch of locations. There's a few other things, like in Discover, let's set this for, no, actually we can just leave this time period. Now let's do one. Let's do the last 90 days. There actually won't be any data here, but you can see that the time picker closed automatically. This is super small, but it didn't used to happen like that, and it's really annoying to have to close it manually. And also there's a back arrow. So if I set it to say, the last 24 hours, and again, this is an older data set, so it's not in there, I can actually use that arrow to scroll back and forward through time. So a few quick small things that are coming in the next release of Kibana that I think are super fun. But what we're here about is machine learning. So machine learning is a new app in Kibana. To be sort of very plain about it, it's commercial, right? So it's a thing that you have to pay for. And that's, the way that we continue to have the opportunity to fly around and do interesting things and be in good places and stay employed. It's also interesting in that I have the ability now to do a variety of things. I can look at jobs that have been previously created, or I can create a new one. So there's a couple of different kinds of jobs that I can create. As I mentioned, beta. The first one I can create is a single metric job, or a multi-metric job. We'll look at a multi-metric job in a second, or an advanced job. We're actually going to, at the time I release this in beta, have a series of videos that walks through each of these and the steps of creating them, from a woman on our team, Asavri, who's just amazing that she can do this kind of thing. Yeah, very soon. Because I'm in product, I can't commit to anything, right? But I can tell you that it's very soon. Excitingly soon. Doing testing now, kind of excitingly soon. The goal is in May sometime. So let's pick an index pattern. So an index pattern is the same kind of thing as it would be an index pattern in Kibana. I've chosen the index pattern of these IT ops metrics because, again, I'm looking at some order data. I'm going to do a low count on my field. Let's do a low sum because I don't actually have a cardinality field of my events per minute. I told it to go ahead and use the full set of data. Bucket span, it can tell you more about it, but the bucket span will be optional, will be configurable depending on how frequently the data is being written, because we're, again, looking at time series-based data. So I'm going to give this a name of, let's call it Basil IT ops. I won't put underscores in it. And then create the job. Again, keyboard fail. So as I create this job, it actually runs the job. And what's happening right now is it's training itself and it's learning the data and it's running through those, all of that data that I have stored, and it's building the model. And then it's applying that model. There's a couple of things here that are visually a little wonky, like these lines. They're gone in the most recent build. Like I said, beta. So let's actually look at the result set. So that's actually run the job. It's created it. It's persisted not only the job configuration, but also the anomalies that it detected. And then as it opens up here in the single metric viewer, it's going to present me with a new display to Kibana, a new visualization type in Kibana, which is a time series viewer that has a sliding window. So that I can look at the entire job lifecycle, or I can drill down to a very narrow period of time, provided that it loads. Is your hotspot on still? There it is. Cool. So let's find a point of anomaly. Here's one. I can see that here is my low sum. I have a critical anomaly in my events per minute. The typical value is 1,810. My actual was 280. So that's that obvious dip that we saw in that last chart. There's some other anomalies in here. Let's scroll over and look at those. Here's one that's perhaps not as obvious without something like machine learning. The actual was 0. But because of how of the low sum of the events per minute, but because of where it appears in the graph, you can't tell that. You can, oh, sorry, yeah. Sorry, looking at Kibana in Zoom view is a little rough. And so you can see that we're not only displaying anomalies that are of max severity, but of things that are lower severity. Like, the typical is 2,185 of this low sum aggregation, but the actual is 1,800. And I can actually choose to only view critical. In the interest of time, rather than building another job, I'm going to use one that somebody else built. The next set of data, so that was actually synthetic, honestly. That's synthetic order data based on an engagement that was done by Prelert, but it is synthetic. This is actually real data that's been anonymized. This is SQL performance metrics. There's another one I could build that's interesting as well. It's based on some airline reservation, but this is some SQL performance metrics. Again, I have the single metrics viewer, but in this case, I have an Anomaly Explorer. And so you can see that it's a heat map style timeline where I have the opportunity to actually, split out the way that I want to do the view. In this case, it doesn't matter as much, but I'm going to choose to dig into this anomaly. And here's the SQL anomalies of these different jobs. So these are multiple metric jobs that are running at the same time. In this case, it's user connections, batch requests per second, the SQL Server buffer manager. If anybody's spent any time with SQL Server, you know that buffer overflows are actually wildly problematic and occur entirely too often. And it actually will give you that detail here, again, for all of these jobs that are occurring. So you can go from as simple to sort of as complex as possible. In this case, the top influencer. So if you think of that metric graph, the influencer in that radar graph was the one that tipped it to the side. The influencer is the host name. So that's a key item that in this case we would want to track. So there's a lot here. The challenge with Elasticsearch or machine learning is that we're not a solution. We don't do a thing. We do a lot of things really, really well. So we have this sort of joke inside of the company that our standard answer for everything is it depends. So, I'll meet with people and they'll be like, hey, will machine learning let me do? And it's like, well, it depends. And it depends on what the data set is and what your periodicity looks like. What we would encourage you is, like I said, this should be available in beta very, very soon. You actually can get a trial license for beta stuff that lets you play with it for like 30 days, which is cool and valuable. Play with it and give us feedback. Because we're keenly interested in seeing this in a couple of different ways. Against real-world data sets, but also against real-world workloads. There's only so much benchmarking and testing that we can do internally before we feel comfortable saying that something scales well in a distributed environment, which is why we're flagging it as beta. Not because something's going to change. There will be updates and improvements, but because we want to see how it scales for people who care about using it. Cool? So that's like the 33-minute overview of what machine learning is about. The summary is, it's all about anomaly detection and time series data, identifying things that you probably can't visually, and then doing that and taking action based on it. Cool? Questions? Yeah.
Does it retrain itself?
Yeah, absolutely. The model is continually updated over time.
Okay.
So if I could rerun that model against the same set of data,
Yeah.
in fact, let me see if I can get back to this view of the single metric of the one I created. So the model will continue to train itself against the entirety of the life cycle of the run. So if the data set grows larger and larger, it'll build that curve better and better. So like, let's scroll this back and look at it. Cool, yeah, here's actually, whoops, let me move this off. Here's a great way to view it, right? So this is the first 3 days, right? And typically the easiest way to think about periodicity is you need 3 intervals. If it's hourly, 3 hours. If it's daily, 3 days. If it's weekly, right? So you need 3 intervals. And then you can see that the model gets closer and closer. What's interesting is look at this anomaly here, right? The question is, at this point, it was an anomaly. But if this same dip had occurred here, it would no longer be anomalous, right? It would become repeated. So it would be the new normal. So you can see that the model has actually taken that into account for the next run. In this case, it's smaller than this dip was, so that it still would have reported it as anomalous. But then it begins to model back towards the standard curve that was happening before. So it can take anomalous events into account. Now, there's always a question of, like, particularly in retail or payments or anywhere that like deals with giant sale days, like Black Friday, is Black Friday an anomaly? And the answer is yeah, pretty much, right? Like, it's outside of the standard operating practice of the business. It's expected. You can flag it as such, right? You can be like, yep, I get it. I'm not worried about that specific anomaly, but it is really an anomalous event when you look at it compared to historical data.
If it happens every week, it will eventually detect it that this happens every week.
Yep.
On Tuesday.
Yep.
Here, it's kind of on a daily basis.
Yeah, and in this case, like, I have a bucket interval of 5 minutes too, right? So if I was doing a weekly set of data, I probably wouldn't have that interval set to 5 minutes. Now, the other thing we're going to do, just as an aside, as part of this, is we're actually going to release, let me go back one page again. All of this is stored in a Kibana index, like all the configuration for it, like, and all of the anomalies, so you can just interact with it in a standard sort of Elasticsearchy kind of way. But But one of the things we're actually going to do is at the time of release, we're going to add, hopefully, barring unusual circumstance, right? It depends, is we're going to add a series of recipes as well. Like, hey, here are common things that we've seen people do, right? Here's a description of it. Here's the kind of the shape the data took, maybe some sample data if we can. And then actually the job configurations in GitHub, right? So like the JSON that would actually define what the job is, right? So you could actually define the job programmatically as well if you sort of so chose.
Do you use one specific algorithm for machine learning, or?
Yeah, it's an algorithm that was developed by the team at Prelert. So, I mean, when we talked about not showing code, like that's part of it, is that one, like I haven't touched C++ in years. So like I couldn't even read some of that code anymore, right? And I sort of muddle through Java code at this point. But yeah, that's part of, call it the proprietary nature of this is the algorithm that was developed to do it.
Do you intend to have kind of a plugging architecture in place that people can have their own algorithms in it? It depends, yeah, no.
Yeah, well, no, that's absolutely something we've talked about, right? I can't sort of guess when, but it's absolutely something we've talked about. Like we know that some people like know their data super well. I just met with a really large company that knows their data super well and has developed an algorithm that matches their particular use case around retail behavior super, super well. And so they want to apply that algorithm to this capability. We would also like the ability to say, hey, you know, this algorithm is super good for anomaly detection and time series data, but what if we wanted to do a different type of unsupervised machine learning against a slightly different data set? So we absolutely have plans to extend and maybe if we can do it and do it well, make it pluggable.
One final remark, thank you for not calling it artificial intelligence.
That was the other thing we talked about. Like, it is a little brain, but that, I mean, that's as far as we went because it's not AI, right? Yeah.
Question, if I may. How do you prevent runaway? Like, in the end, the thing learns that, well, it's totally normal that you wait 3,000 milliseconds for your request. Does it do that? Does it take that into account, you know, slow progression of runaway? Like, for example, yeah, you have a request which takes 3,000, takes at the beginning maybe 50 milliseconds, and it goes slowly goes to 55, 60, 70. I guess it would learn it.
Yeah, but it would be sort of ever increasing, right?
Yeah.
But it couldn't be.
Does it do that? Does it take that into account?
You know, I honestly don't know
Okay.
because I haven't seen anything that because like that. I don't have a graph up, right? That graph wouldn't have the same periodicity, right? It would have sort of an increase.
Should, yeah.
Unless it came down at some interval and then it increased again at the same way, right? And then you'd have the periodicity again. So yeah, I'm not sure. I haven't actually tried to run it against data that was like a request response that increased by 50 milliseconds or some logarithmic function over time.
I think that, but that is also an interesting use case, a combination of what you can use Watcher for, because there you probably say, hey, 500 milliseconds is the limit you want to reach, and you're going to combine the learning algorithm and the Watcher. Say that is the maximum, but also learning. So I kind of assume it would learn it actually. But
Yeah, but I'm not.
learning still.
Yeah, but I don't know, so I don't want to say yes in case I'm wrong. Cool. Other things?
Can you do also analysis of content? I mean, right now you do values, but can it also do, for example, let's say you have a, I don't know, a data set which is regular.
Mm-hmm.
Let's say cron job runs at periodic interval. You get a request from this and this machine at this and this point. All this, for example, generates your syslog or whatever it is, and can you say, can it differentiate between, for example, something that's periodically okay, and then you see suddenly requests pop up which are either which do not exactly match what it's usually seen.
So this is a job that was written, provided it loads, to look at anomalies in IT operational logs. And in this case, I don't have any great anomalies, but there was an unusual message count for the machine learning category. And the category is here, the actual's 4, it's a count. So that's still applying an aggregation against the content rather than doing like actual content analysis. Yeah, but you could see that we in this case, and one of the use cases where we do see people run it against is against log data. Again, frankly, I just haven't been able to play with it enough to know how it plays with content itself.
I mean, it's already cool, so.
Yeah, totally. I'm super excited about it, right? I mean, granted, I'm a giant nerd, right? And like, I love talking about stuff, like as I said, other people built, but yeah.
Would it be possible in the future to use it as a prediction stuff, so you can say, I have 1 month of data in it for sales, then I can predict the next month how it will be, or have 1 year in it, and say how it would be July next year for my sales.
Yeah, I mean, that's not really the usage of it right now, right? In that it's looking at prior data, but it is something that comes up, and it is something that not really the machine learning team as much, but other teams have looked about, which is like, how can we do predictive analytics? It's hard, right? Because like, it's, yeah. But I mean, I'm doing it against existing data rather than saying, I mean, if the model holds, you could say that this would be the same at this period in the next year. The question is like, if it increases, how does that change the calculation? And so no, it's not really what it's designed to do right now. But I think you can see where it's not a big leap to head that direction.
I know there were in Call, where we had the engineering meeting, the machine learning team actually discussed about that it should work.
Yeah.
Nobody tried.
It should work, but like we've been so focused on getting this bit working right, because you're right. I mean, that's in essence really what we've done, right? If you can define a model against periodic data and say that this periodicity is going to occur regularly, then you'd be able to predict what the future periodicity should be within a margin of error, right? And you could even apply growth factors to it. But yeah, it was. So, you know, Elastic is almost 500 people now, but in 32 countries and 19 time zones. So like, we just hire people and let them work from wherever they live. But we get the engineering team together twice a year. It was in Tahoe earlier this year, where everyone gets together and sort of breaks out into groups and talks, and it's a whole lot of fun and very tiring. But yeah, all of the great ideas come out of that, out of those meetings. Cool. Well, if you have other things, we're both around. Thank you so much. I appreciate it. It's super rainy out, so I'm glad that folk came. Cool.
Thank you, Tyler.
Thank you.